Video we are going to be modeling about kids bed. It will be a complete bed which is parametric and will be able to be edited anyhow, anytime, depending on the type of the space and the size of the space that you have. So let's get started. Since it is a family, you will go to new family, then scroll down and choose generic model. So the first thing to do is to choose the units to work with by simply clicking UN as the shortcut. Then let me set the units distance to millimeters, length to millimeters as well. So after setting the units, the first thing we must do is to set the reference plane. So since it is a bed, we will need the two reference planes, the two horizontal and the two vertical and two horizontal, and we have to make the distance equal by using the dimension here and then set them as equal, and do the same here and then choose equivalence to have them equal. So while being on this reference level, we are going to set the parameters. So this will be the width of the bed and this will be the length or the long side of the bed. So to set parameters, we have to click on the dimension, then here create a parameter. Let's call it W for width, and do the same here and call it length, L for length, to keep it short and simple. So then let's go to the front view and also set the reference plane. Since our bed will need height, obviously, so we need to create a reference plane. Let's say this one, and also give it dimensions and then give it a parameter as well, because we want to be controlling the height of the bed, and give it h for height. So we can also need offset, but this time no need for an offset, since most of the beds for kids also will be having like storage under the mattress, so it's better to not have an offset. So let's go back to reference level. So since our bed, the bed we want to be modeling, must have like the storage here on the side, so we'll go to right side, then create extrusion. So we have to lock all the sides to our reference plane so that changing the parameters will not affect, so that the shape will move with the parameters as they change. So we also need to offset. I will show you the other way to use instead of offsetting. So let's click finish, go back to the reference level to fit the whole shape in our parameters that we have. So we will move our shape to this reference plane and lock it, then move to another reference plane and lock it as well. So we can check how the shape will be looking in 3D. This is how our shape is so far. So we need to have storage here, so we need to be having storage in the side, as I said. So let's go back to the right view and create a void. So we will go to create void extrusion. Then this is where we will determine our, like, the depth of the storage that we want. So let's offset by 25 millimeter. Then do the same here. Let's make them equal. Then set parameters as well. So let's call it D as depth, then TH for thickness. Okay. Then we can change this W headboard to, let's say, 1400 millimeters, then hit OK. Then go to front view. So the front view, we have to set the height. So create reference plane, choose dimension, then add this dimension and create a parameter and call it HB as height for headboard. Then, so let's create the extrusion for our the below part of the bed. So create extrusion. So use this rectangle icon, then lock it. And so let's use this fillet to trim the edges. So we can set the radius to, let's say, to 10 centimeters, then offset it like this. So I don't want to set it as a parameter, since I will have it fixed to this 50 millimeters. Okay, let's trim or tiara for trimming the ends to have closed lines, and then hit OK. Then go to ref level. So you have to align this outer part. So since we'll be having also the inner part of this particular shape, so let's align it to this reference plane, lock it, and also this one, and lock it. So we also need to have, go back to front view, we also need to have the shape here inside of this selected shape, this modeled shape. So we also need to create extrusion. Let me use pick lines, then pick the lines. Okay, then hit OK. Then go back to ref level. So I want this part to be inside of the first shape that I selected, so that I modeled, sorry. So I have to create reference planes on both sides here, and another one here. So I will also set the offset to, let's say, 70 millimeters, 70, or no, let me set the dimension also for this inside part. So let me call it th2 to mean the thickness for the second part. th2, hit OK. Then this one, call it inner material. Okay, so by this we can be able to control materials and dimensions of this part. So let's save it before loading it into the other family. Then file, save as family. So let's call it below part. Is save. Okay, then we want to also create another family. So want to create another family, go to new family, choose generic model here, open. Okay, so this family also UN for units. You have always to remember this to set units before. Millimeters, also millimeters. That's what for me I use. Okay, then so the headboard that I want to use, or the upper part, the part of the bed which will be where the pillows will be laying and the head. So the headboard, I want to have a cushioned portion of it. So I want to set also the reference planes vertically and horizontally to set depth and width of it. So I'll drag to first set equality, set equality again, then set parameters for width and depth. Sorry. Okay, so add parameter, let's call it WHB2 depth. Okay, then we want to go to the front view and also set the reference plane, this one, the reference plane, then set height. So since we want to be controlling the height, it has to be also parametric. Then let's call it HB2 meters, hit OK. Okay, then go back to the ref level, then create extrusion. You can use peak lines or rectangle. I use rectangle so to be fast. Then always remember to lock it to these reference planes. Then after locking it, let's use fillet and use the same 10 centimeters. Okay, fillet. Okay, so we want to be controlling also this fillet. So the thing I'm going to do is you select or click the fillet before hitting finish, then select on this dimension line to make it a dimension. Do the same here, do the same here, and do the same the same here. Then select all, go to filter and enable dimensions only, hit OK. Then set it parameters and let's call it fillet. Headboard, save. Okay, load it into family 4, hit OK. Then let's place it here for now. Then also let's go for, okay, this is our bed base, so load it into family 4, hit OK, then place it here for now. Okay, then let's go back to, so let's first close these families because they are being too many and too distracting for now. So let me close them. Okay, so we have this family, so let's save it and give it a name as kids bed. Let's call it parametric kids bed. WDR and call it DDR as depth of the DR. So go back to, so we need the height of the drawer, yes. Okay, so go back to the ref level, and set, so we have to also create another reference plane here. So this reference plane will be the thickness of the back part of the drawer. Then this thickness will, I want to have it fixed and give it 2 centimeters. So I will change to 20 millimeters. Then hit blank space to bring it inside. Okay, then since we want this part as the front part to be open, so it will not be closed, hit SL for split and for split elements, then TR for trim and extend, like this. Okay, then before hitting finish, let's lock the thickness to 20 millimeters or 2 centimeters. So select this one, lock it, but instead of locking it, you can also give it a parameter so that you can control this, but it is not necessary since it is the standard dimension. So let's lock it, lock, then hit finish. Then go to the front view. We also want to lock it, to lock this this inner part of the drawer, but this inner part will not be as tall as the height of the whole drawer. So we want to create the reference plane here, and let's call it, sorry, go to annotate, aligned, then give this a dimension and a parameter as well. So this parameter will be, let's call it h inner. So as the height of the inner part, let's call it h inner. So select the dimension and lock it like this. So go back to the ref level, create extrusion, yes, then lock it, okay, then hit finish, go back to the front view and align this and this one here as the base. So let's align also this here and lock it. So this is it, this is the front, so this is the inner part of our drawer. So let's join the two shapes, select join, select the upper part, select base to join it. So this looks nice. Okay, go back to the ref level. So on the front view we are going to model like the front part of the drawer, or the one to close up this this drawer. So we are going to create extrusion. So let's offset it by, okay, no need of offsetting. I think having it this way will look nice. Then lock it and lock it, then hit finish, go back to the ref level. So we want to have this front part here in front, so we need the second reference plane, another reference plane here. Then we would also like to lock it by 20, go down oblique like this, or this one, then trim the lines to have a closed shape. Then let's delete this one. So hit finish, go to the front view. So as you can see, we can now change the edit plane, pick a plane, then let's choose this reference plane. So after selecting this new plane, we can set the length of the handle as a parameter. So let's create a new parameter and call it length handle. Okay, so let's check our parameters for now. So in 3D view, you can now see that the handle is now correct in our model. So let's check if our parameters are still working. For example, the height of the drawer, so let's put 300, hit apply. So you can see that you can control it. But for me, I'd like to also make a system where this height of the handle will always be taller than this inner part of the handle, or of the drawer, sorry. So I would like to, let's bring back for example to 400, hit apply. Then this height of the inner part, give it a formula which will be equal to HDR over 2. So it will be always a half of the whole height. So hit apply. So you can see that by the time where I will be changing the height, for example to 600, automatically the inner part of the drawer will also shift. This is what I mean by parametric furniture. So let's bring back to 300, hit apply. So you can see that everything is good. So let's check the depth for example to 300, hit apply. Okay, let's bring back to 500, hit apply. Okay, so let's check the length of the drawer, of the handle, sorry, and give it for example 500, apply. So you can see that it is changing. So far so good. Okay, then the next thing we want to do, we want to set the movement of this drawer, which is the most important thing in this parametric design of a drawer, so that this drawer will be also operable. We can open this, close it as we want. So what we want to do, we want to set the movement. Okay, so since we want, so we have to consider, so we have to create the reference plane right here and give it a dimension. So to mean that by the time this drawer will reach here, the drawer will be fully opened, and by the time this drawer will reach here, we will be having a closed drawer. So let's call this let's give this dimension a parameter and call it movement. So for adding a movement to these cabinets, we have to change this the way we added the parameters. That's to mean you have to change or to redo some of the parts. So this dimension, let's have it here. Okay, then let's call this dimension depth. Let's call it DDR. Okay, then delete this one because it is useless. Okay, we are going to make the model, the extrusion in the front view. So let's start by extruding the inner part of our drawer. Okay, then lock it, and lock all the sides. then let's offset by 20 millimeters to 20, then lock it. Align this, lock it, align it here, then lock it. So in 3D view we have something like this. So let's first check how the parameters are working so far. So go to the family types, then for the movement let's change to 300, hit apply. So I think it is moving, but in a negative direction. So what are we supposed to do? So this means we have to let's first delete these parameters. Yes, let's delete the depth again. There's still some mistakes, I'm so sorry. Okay, then this means we have to add another reference planes. So the reference plane will be here, so that you can have this pinned reference plane to be like the last plane to use. So this one will be the movement parameter. Let's call it movement, 20 millimeters. So give it a dimension and lock it, then align AL as a shortcut, or click this icon, then align and lock it, then align again this one, lock it, align and lock it. So the next thing we are going to do is to check again these parameters. So let's check this to 0, hit apply. Okay, you can see that our drawer is able to move. Hit OK. So let's check the 3D view, our 3D. So there is a bit of a problem here. So I think this one must be moved and be locked on the back. Okay, like this. So the next thing I'm going to do, go back to the front view, create an extrusion, add the front part of the drawer. So lock it to all reference planes, hit finish, go back to the ref level. Then we are going to add again the reference plane here as the host of our front part. So we have to give it 2. So hit apply. Okay, then the depth to 400, hit apply. Okay, then the movement to 100, apply. Okay, so far so good. So what you're going to do now is to add the handle. So let's go to the right view or left, whatever you want. So we are going to create a void extrusion. For the void, okay, move by 5 hit OK. Then associate this and call it H. Okay, let's call it H base. So after associating all the parameters to the family, you're going to align this headboard piece to the top of the bed base. So align, then lock it. So for it to make a full width of the headboard, we need to use the array group, the grouping by array. So since we need to make a system of the whole bed, which will be editable without editing single element of the bed, we need to form a formula by moving the first two to the last. Then the first array, we need to move it to the last, and numbers set them to 2. Okay, so we also need to add a formula. Then by adding a formula, we need to select this line showing numbers, then add a parameter. Let's call it numbers. So these numbers need to have a formula, so we have to go to the family types, scroll down to the others category. Then we want to have the width of the base, and divide it by, so let's say, for example, W base, this is the formula, divide by, let's say, 200 millimeters. Hit apply. Okay, then hit OK. So you can see that the formula, the headboard is now made up of a repetitive cushioned elements, but which can be controlled or follow the width of the whole bed, to mean as the bed change, the headboard will also change. But this below part will not change unless we also add a formula. So the formula here will be like the width of this lower part must be equal to the width of the bed base, so that changing the bed base will also change this lower part automatically. So let's see. So this is the width, the WHB. Where is it? Where? So sorry. Oh, the parameters, its parameters were not yet associated with this family called Parametric kids bed. So let's first associate them. So add depth HB as the depth of the lower part of the bed. Add HHB. Okay, add the thickness th2 as the thickness of the lower part. Okay, then add WHB as the width of the lower part. Okay, so go back to the family types, then go to the width WHB, which is the width of this lower part. Then to give it a formula, it's just to say that this WHB is equal to W base. Then hit apply. This is to say that whenever we change this width of the base, let's change it for example to 2000 millimeters. Hit apply. So you can see that the lower part of the bed is changing, but these headboards are not changing because we kept the millimeters or the distance to be divided to 200 millimeters. Let's reduce the distance and for example divide by 100. Apply. So you can see that the numbers are increasing, but are not from the edge of the bed. So let's correct this by aligning or locking this cushion to the bed. Okay, so let's repeat the process. Let's also align. Let's align this one. Okay, then add the formula again. Okay, so you have to first delete this formula, these numbers. Okay, so sorry. Okay, let's move a copy. Then align this one. Okay, then turn it to array, then also align this array and lock it, then change this parameter to numbers. Let's call it numbers again. So the constraints between geometry and the family can behave unpredictably. Okay, so let's add the formula and see. W base over 200 millimeters. Hit apply. Okay, then let's change the base. So since we hit apply, since we repeated the last operation, we have to bring back these parameters. DH as the depth of the first headboard. Hit OK. H as the height of the lower part, add, okay, let's do this, okay, okay. So let's go back to our family types, then change the width of the base to see how the system is affected. Hit apply. Okay, so you can see that the headboard, as the width changes, the cushions also will multiply or will change in size as the width of the bed base is changing. So this is the system, but you also have to add the formula for this width of the lower part, so that this lower part can also be in the system. So the system will, the formula will be just to say that the width, the WHB must be equal to W base. Hit apply. Okay, let's change the W base, for example, to 130 centimeters. Hit apply. Okay, so hit apply. So let's, for example, change the width of the second headboard. For example, let's say 120 centimeters. Hit apply. So here the constraints will not be satisfied since the headboard is already in the system. Okay. So the other thing we need to do is to add the drawer. We need to add the drawer. Okay, this is how our bed is looking so far. So we need to add the drawers into this storage, this bed storage. So what we need to do first is to lock these elements to the reference level. Align, then lock it. Do the same. Lock it, and so for here, since we have a system, we need to first select all the groups, group them. Okay, then select one as a group. What? Okay, then align it to the reference plane. Okay, so go back to 3D, then have to add the drawer. So this drawer must be first rotated. Okay, then we need to add a reference plane as an extrusion or an offset, as an offset of this drawer, so that there can be spacing between them too. So let's mirror this. Then add equality. Okay, then add dimensions and lock it. So align this drawer to the reference plane, lock it, then also we need to find the formula for the width of this drawer. So the formula will be equal to the length of the bed divided by 2 and minus 13 millimeters. So go to family types, to the width of the drawer, which must be equal to the length of the base over 2 minus 13 millimeters. Hit apply. Okay, so you have to align the drawer inside. So this drawer, the depth of the drawer must also have a system, so that whenever we change the width of the bed, the width of this drawer must also change automatically. So what you have to do is to first align the drawer. Okay, but don't lock it, because we need to be moving this drawer, opening it and closing it. So locking the drawer will bring a restriction which will not enable the movement to occur. So what will be the formula? The formula will be that, but I think on the width of the drawer, we must also subtract this 25 millimeters, so that this drawer will be fitted inside of this void. So the formula will be the length of the base over 2 minus 38 millimeters. 38. Okay, hit apply. So to change this, we must, okay, we must set the depth of the drawer as a formula again. The depth of the drawer, where is it? The depth D drawer, I think it is this one, depth. Let's check. Okay, so we have to add the formula here. Says that the depth of the drawer must be equal to the width of the base, W base, over 2. Then hit apply. So we also need to lock this drawer to the bed so that they can be moving. If the bed moves, the drawer must move with the bed. Okay. So we need to lock this. So we need to lock this drawer to the middle of the bed. Lock it like this. Let's hit OK. Then let's check the movement of the drawer. So okay, you have to okay. So let's first bring this movement again to 0, hit apply, okay, hit OK, then we have to first adjust the movement to its maximum. So this movement, its maximum is about 700, okay? 700. Did 700, hit apply, okay? Then we have to align this drawer kit. This is the line that where the movement was starting. So you have to align it to the bed like this, and again check the movement at 0, apply OK. Now the drawer can move smoothly without compromising any system. So what we have to do now is to duplicate and copy this drawer to the other side. So the reason why we need to duplicate it is to have a full control on the movement, so that we will have two different parameters. Let's see. So let's first mirror a copy of this drawer to the other side, then we have to duplicate it first. Duplicate it, okay, then add these parameters so they will be having the same name except for movement. That's why we have to create another parameter. Okay, this one is the main dr. The depth must be the same, the height must be the same. Okay, the height of the inner part must be the same, the length of the handle must be the same, but for movement you have to create another parameter and call it movement 2. Okay, hit OK again. Then for the width of the drawer must also be the same. Being the same means they will also share the formula. Okay, then let's first lock this drawer to this reference plane. So align it, then lock it. Okay, then to fix it, to lock it on the middle of the bed, we first have to use this movement to its fullest. Hit apply, okay, then align like this. So align the bed, then go back to parameters, change movement 2 to 0, hit apply, okay, check for example for 400, hit apply, okay. So you can see that our bed is now fully parametric. So the next step is to check the 3D and adjust the height of these drawers to be equal to the height of this bed base. So what we must do is to go back. So let's first delete these, we no longer need them. Okay, I have to go to the family types. Okay, check the height of the drawer. HDR must be equal to H base, must be equal to the height of the base, must be equal to H base. This is to say that, so what's the problem? Let's first look these drawers. To this reference plane and lock them. So the problem here, so I'm asking why is the formula not working? So we need to go back to edit type and check this formula for inner height, remove it, remove the formula, hit apply, okay. Then load into parametric kids bed, save changes, okay, override the. So we have the constraints here, okay. So we need to fix so by constraints they are saying this locking of the drawers. So let's check the formula again. Oh, we used where the height of the drawer must be equal to the height of the base. Then height of the inner must be equal to height of the base over 2. Okay, hit apply. Okay, now the bed is fully parametric. So you can check the bed. You can also change the materials. For example, let's change the base material, for example, to the wood. Let's use brush, hit OK, hit apply, then OK, change to the realistic to see the changes. You can see the birch material is applied. So let's change this front of the drawer, for example, add an MDF. Let's change its color to white. Okay, then reduce the image fade, apply. Okay, can see the change. Let's change the outer material of the headboard. Let's use, for example, gypsum. Apply. Okay, apply. Okay, let's copy this gypsum. No, let's copy this MDF to the outer to have the same materials. Okay, let's copy this MDF. Okay, what? Apply. Okay, then change the inner material, for example, to the birch. Apply. The inner material is not visible because it is in the drawers, but let's change the, no way, sorry, you didn't change the, okay, this is the birch. So let's change the HB2, for example, give it a fabric material, let's say apply leather. Okay, Okay, hit apply. Okay, apply. Okay, so you can see how this bed is now fully parametric. So if you like the content, if you are interested in modeling the families which are fully editable and parametric, please consider subscribing, sharing and liking. Thank you.